Hello everyone, welcome to part 1 of my video series on statistical significance analysis. So in this video we are going to talk about the very basics of statistical significance analysis and hypothesis testing framework. So let's dive in. So let's start with a very simple question. Are Bangladeshi men significantly taller than Bangladeshi women? Now Bangladesh is the country where I live in. So this is the question. Now the question is, how do you objectively answer this question? In order to answer this question, suppose we do one thing. We have to collect some data, but obviously it's not possible to collect the height of all Bangladeshi men and women. Nobody can do it. So what we do is we collect some sample heights. We collect height of 1,000 BD men and 1,000 Bangladeshi women from different parts of the country. Okay, so this is what they look like, suppose. So these are the heights of different men and these are the heights of different women. Obviously, there aren't 1,000 points here, but just imagine that there are 1,000 points. Now, some people may say that, okay, indeed, men look like they are taller than women, but some people may also say that they are not that different. So, like, what's up with that? That means, in order to answer this question, we have to be objective about it. In order to do that, we have something called hypothesis testing framework in statistics so that people cannot really argue and debate through visual inspection. So let's talk about this framework that I keep bringing about. So there is this thing called null hypothesis, which is called H0. So in H0, we are gonna just say that there is no difference between BD men and women in terms of height. And this is something we want to disprove. So basically, first of all, we just assume that this is true, but we have to disprove it in order to prove the alternative hypothesis H1, which is BD men are significantly taller than BD women. This is what we want to prove, and this is what we want to disprove. Okay, fine. Now, in order to do this, we have something called p-value. So what is p-value? Very, very important. Pay attention here. P-value is a probability. So what is the probability of the null hypothesis being true? That means, but in this case, what is the probability of no difference between men and women height in BD, given that we have observed the heights of 1,000 BD men and 1,000 BD women. So again, let me clarify this. We have observed 1,000 BD men and 1,000 BD women and their heights. So given that we observed this, what is the probability of the null hypothesis being true? That is called p-value. Now, if our statistical test gives us a p-value of less than 0.05, that means there is less than 5% probability of null hypothesis being true. Then what we can do is we can reject the null hypothesis. That means we can say that, okay, this is not true. That means indeed BD men are significantly taller than BD women. Okay, fine. Now the question is, how do we get the p-value? Now this is obtained through statistical testing, and this testing can be quite different depending on the problem at hand. For example, this is a particular kind of problem, but we have many different types of tests in statistical testing. I'm going to give you some example in the next slide. So let's see those examples. So this is one example. Suppose you have 200 cancer patients and you have given a certain drug to only 100 patients. Now the question is, does this drug improve patient survival significantly? Okay, so obviously the pharma company who designed that drug will claim that, okay, it does significantly better, but we have to understand statistically whether it does improve patient survival significantly. So this is one type of significance test, and you can use some specific test to actually test this. Then there is this particular example where you have recorded annual income and marital status of 500 women in Bangladesh. So marital status can be married or divorced. So the question is the marital status of a woman significantly correlated with her income level? So often people say that if a woman has a higher income, she has a higher divorce rate. So is that actually true? So we can actually test that using the data that we collect. Then this is another one. So suppose you have recorded the mutation status. So you know that we have DNA, and in DNA we have mutation. So you have recorded mutation status of certain gene in your DNA in 5,000 cancer patient and 5,000 healthy patient. The question is the gene mutation status significantly enriched in cancer patients compared to healthy people? So it just means that whether cancer patients have significantly more of this mutation compared to the healthy people. That's what it means. So all of these require very different significance testing procedures, and we are going to talk about a lot of different significance testing procedures in our upcoming videos. I will try to cover probably 14 measure of them so that you can have a very good idea about all of these, and I will give you like practical examples of each of them. Okay. So now in statistical testing, we can make error definitely. Obviously, people are error prone. So there are two types of errors, type 1 error and type 2 error. So let's talk about type 1 error first, which is called false positive. So the question is, what the hell is false positive? So let's talk about cancer screening. I mean, I just want you to visualize an example to understand what is false positive. So suppose you have a tool and it detects cancer, right? So if the tool detects cancer, that means it sort of predicts positive, but the patient actually has no cancer. That means it's a false prediction. So this is going to be a false positive because your tool has given a positive prediction of cancer. So it's a positive prediction, but the patient in reality does not have cancer. So it's a false prediction. So it's a false positive. Now, this is just a simple example, but this has nothing to do with statistical testing that we are talking about here. So let's talk about in light of that. For example, let's talk about the same example, the example of height difference between BD men and women. So again, we have this alternate hypothesis that BD men are significantly taller than BD women. So the thing is, in this case, if we falsely accept the alternate hypothesis, that means if we falsely accept H1, that means we say that BD men are indeed significantly taller than BD women, then this is type 1 error. That means we are falsely accepting the H1. That means we are falsely rejecting the null hypothesis. So the basic thing is, whenever you falsely reject the null hypothesis, then it is going to be a false positive. Okay. Now, here is the thing. I mean, this is basically what I was talking about. So you conclude that BD men are significantly taller than BD women, but in reality, maybe there is no difference. If that's the case, then this is a type 1 error. Now, type 1 error has a lot to do with what alpha value you set, because previously we said that if the p-value is like less than 0.05, accept the alternate hypothesis and reject the null hypothesis. So as I said before, 0.05 or 5% means that there is a 5% chance of the null hypothesis being true. But since 5% we consider it to be a very small number, so we just say that, okay, we don't care about that, so we just reject the null hypothesis. What does that mean? That means that there is actually a 5% chance of falsely rejecting H0. Now, if you don't want false positives at all, you can actually set a tighter threshold for alpha. You can say that alpha equal to 0.01. That means even if there is like 2% chance of the null hypothesis being true, you are still not going to reject the null hypothesis. That will allow you to have a better false positive. So basically by better, I mean like lower false positive. Okay. So that means the moral of the story is, if you reduce the alpha, if you make it more strict, then you are going to have a lower false positive, right? So that brings us to the next point, which is the type 2 error, which is false negative. So again, we give the same example to start with. So if your tool detects healthy, that means it doesn't detect cancer, it's a negative prediction. But the patient actually has cancer, then it's a false prediction, so it's a false negative prediction. And we give the same example of height, and you actually now know what's going on, because if we now falsely accept the null hypothesis, if we falsely accept H0, that means we actually fail to correctly reject the null hypothesis, then this is going to be type 2 error. So it's the opposite, it's the flip side of type 1 error, basically. So, I mean, just to give the example, if you conclude that BD men and women have similar height, which is the H0 hypothesis, but actually men are indeed significantly taller than women, then obviously you have wrongly accepted the null hypothesis and you have made the type 2 error. So there is a parameter called beta, which is not widely used, or people don't really talk about it that much. So beta is basically the probability of failure to reject H0. So I remember that alpha was probability of the null hypothesis being true, but beta is the opposite. It's the probability of failure to correctly reject the null hypothesis when indeed the null hypothesis is false. So again, let me clarify. So H0 suppose is false. If H0 is false, what is the probability that we fail to reject H0 and we fail to accept the H1, right? That is beta. Now, this false negative parameter will increase when your significance level alpha will be decreased. So it's the opposite of the previous case. So when you decrease alpha, suppose you decrease alpha from 0.05 to 0.01, then you are gonna have a higher beta, right? Because in that case, suppose if you have alpha equal to 0.01 as the significance level, then even if your probability of the null hypothesis being true is 1.5% only, still you cannot reject the null hypothesis because it is not lower than 1%. 1.5% is still larger than 1%, and it will actually make the probability of accepting a wrong null hypothesis much higher. Also, if your number of samples collected is too small, then it is going to be very hard for the statistical test to appropriately reject the null hypothesis, because these tests are very conservative sometimes, and if you have like 5 BD men and 5 BD women to test against, then probably your null hypothesis will not be rejected because there will be very limited statistical power to accept the H1. So that is all about the first lecture. I hope that you now understand, you have an understanding about the hypothesis testing framework. So if you like the video, feel free to subscribe and share. And there is a link in the description for donation. If you want to help our channel grow, you can donate to our channel as well. Thank you very much.